It's a C++ library that allows you to create local key value databases. But what makes this particular C++ library so fantastic is some of the attributes of this. First of all, the Python wrapper is fantastic. It's super, super simple. I have some demonstrations I'll show. My demonstrations were actually so small I had to add extra stuff to it just so they looked like real files, and you'll see that. And the second thing that makes this so fantastic is that when you create a Kyotocabinet library or database, it's memory mapped, which means that the whole file is assigned virtual memory addresses on creation. And that means that the disk I/O is way faster than a normal key value database. And it also means that you can actually load parts of it right into memory off the bat, zero or the whole thing, it's up to you. And this becomes extra, extra awesome when you use it for Chango, my company, with concurrent processes. And in this case, you can load this whole thing into memory, and it's shared across any process that tries to use it. So in our application, we have about 50 different, we have a web server with 50 processes handling hundreds of requests a second. And normally, like, we just can't afford servers with enough RAM to load these things and share them between all the processes. But with Kyotocabinet, that's not a problem, because with memory mapping, it's all totally shared. You can have as many processes or as few processes as you want. You're going to use the same amount of memory. Either way, it's fantastic. So I'll go over now to my little demonstrations just to show how simple this is. No, not that. Here we go. So on the left, I'm creating the cabinet. And in this case, what I'm actually doing is taking the text of Ulysses by James Joyce. I just tried to pick a long, boring book. And I'm creating a key value database where the key is a word and the value is a list of all the lines that start with that word. So you can see how simple the Kyotocabinet is here. There's about 4 lines, maybe even less. So you just import this, instantiate this DB object, and you open a path to the file. The path doesn't even need, this file doesn't even need to be there. It creates it automatically. And you can also specify a huge different variety of options. If I had made this a KCT instead of KCH, it would have used a tree index for my keys. H means hash index. I could have specified the amount of memory I wanted preloaded when I opened it. I could even specify things to the level of the bit distance between keys. If you have a database that's doing a lot of sets, you can set a wider distance that allows more keys to be set. If you're doing mostly reads, you can have a lower bit distance so that, anyways, the point is, this is like the absolute simple thing. There's so much more that can be done with this that I'm not getting into. The website's fantastic and lists all this stuff. So I open it, specify that I'm creating it, iterate through my James Joyce text. All I do is this db.set here to set my value, and that's it. That's all there is to it. On the other side, again, like it's hard to make a complicated Kyotocabinet thing, so I tried to sort of beef it up a little bit with 2 different examples that will run concurrently. There's 2 processes down here. In the first one, I was curious about, I took the most popular words in the English language that I got off Google, and I want to see how many lines those words start in James Joyce's text. And in the second example, because I thought James Joyce was very boring, I honestly did try to read it, but it's really not very interesting. So I'm going to see how many times the word lame starts a sentence, and then also what the most popular starting word of a sentence is. So let's just run these. So we create the cabinet, done, and then we can run the script, and that's it. So you can see, no surprise, the is the most popular word. Lame appears 47 times, and you can see some of the more interesting words that start James Joyce, and that's pretty much it.